How's it going, everyone? Mitch here with a C Sparks tutorial. In this tutorial, I'm going to be talking about basic electrical concepts. To start, we need to talk about charge. Charge is a basic property of matter, and at the lowest level is the elementary charge, the charge of one proton and the charge of one electron. They have both this exact same magnitude, only the electron is negative. Now, if we are to look at the standard units, which are usually coulombs, which we abbreviate to just large C, 1 coulomb is 6.24 times 10 to the 18th electrons, which is quite a bit of electrons. Now, if we were to look at current, we can define current as a time rate of change of charge. And if you look down here at this relationship equation, you can see that it's the change in charge over the change in time. And that's how we defined it. Now, it's important to note that current has magnitude and direction. If you were to view it on a circuit, it would have a certain magnitude associated with it, as well as a direction on where that current is going. Now, it's also important to note that current is the opposite, the flow of electrons. If we were to look at a circuit, we usually define current as coming out of the positive terminal of any source. It turns out that current comes out of the negative side of the source. We use this property just to not get confused when we go to start analyzing circuits and whatever. It doesn't affect any of our solutions at all. This is how we define current. Next, let's talk about voltage. Voltage can either be called the electromotive force or potential. If we look at units, we can define this as work over charge, or joules per coulomb, or volts. And as you can see from this relationship equation right here, voltage is the change in work over the change in charge. And that's how we defined it earlier. Voltage difference between 2 points is a difference in energy level of unit charge at those 2 points. If we were to look at these two examples over here, we can see that the positive side of this, whatever is in this black bubble, is going to have 10.3 volts across it, and the positive terminal is going to be 10.3 volts higher than the negative terminal. The negative terminal doesn't have to have 0 volts. We're just saying that it's 10.3 volts higher than the negative terminal. Now, if we were to look at this is just another way of defining voltage over two nodes of a circuit, and that's voltage from A to B, or VAB, can be defined as 10.3 volts. We'll see that come up here quite a bit. The work required to move a charge through an element is defined as the integral of the power from T1 to T2, or over a certain period. Now, we can look at power as also voltage times current. And if we go to the next one, we are going to find that right here. Power is joules per second, and it's the rate of energy expenditure. Now, if we look down here at this equation, we can see that power is voltage times current, and we define voltage as the change in work over the change in charge, and we define current as the change in charge over the change in time. Now, if we were to cancel both the charges on both the voltage and current, we end up with the change in work over the change in time, which is exactly what we defined power to be. So if you want to know a bolded equation from your book, it's P equals IV. Power is volts times amperes. Alright, and if we were to use this exact same example that I saw in the last one, only add a current, it would be power equals 2.4 amps times 10.3 volts, which ends up with 24.7 watts. Let's talk about independent and dependent sources. Let's start with independent. You can see here that there is a DC voltage, and then down here is the DC current source. And then also, right beside them are their sinusoidal or AC brothers. Alright, so here is the sine generator for an AC signal. That's going to be in voltage. And then there is also an AC current signal generator that we can see right here. Now, down here at the bottom is a different notation, and this is basically how you define a battery, but it's just another DC source. Now, if we were to look at dependent, we can see that there is current and voltage. Now, dependent sources are controlled by another part in the circuit. They could be controlled by another current, or another voltage for each one. I will actually have an example here, which will show you exactly what I mean. Alright, here is the example question. Here is a circuit, and we have three elements. We don't know what they are, but we just know the current going through them and the voltage across them. And if we know both of those things, we can find the power associated with each of those elements. Now we need to find the power absorbed and the power supplied by each element. And then we need to make sure that the absorbed power and supplied power equal each other, because we can't create or destroy power in any circuit. Alright, and as you can see, this dependent voltage source is dependent upon Ix, or this current coming out of this 36 volt generator. This voltage source is dependent upon current. It could also be dependent upon voltage as well, but in this case it's not. So let's see the answer to this question. I'm not going to spend too much time going over this. You can pause this video and check out my work here. Thanks for watching this C-Sparks tutorial. If you would like to access the blog which I run alongside this YouTube tutorial channel, I will post a link in the description below. In the meantime, feel free to check out my next tutorial. Thank you.